Welcome back, everybody. We're going to finish out Chapter 2 by solving compound inequalities. So let's start with what is a compound inequality? An inequality formed by joining two inequalities with the words and, or. So we have two inequalities and we're kind of squishing them together into one inequality. The graph of a compound inequality with and is the intersection of the graphs of the inequalities. The graph shows numbers that are solutions of both inequalities. So if I'm looking at x is greater than or equal to 2, and we have this graph here, and then x is less than 5 has this graph here. So their compound inequality solution, if I go from the end of 2 and the end of the 5, then you see these values are both shaded. So the answer is where the 2 started, the 5 stopped, and then where their shading was the same. Okay, their shading was the same. The graph of a compound inequality with or is the union of the graphs of the inequalities. The graph shows numbers that are solutions of either inequality. So basically what we're doing is we're writing down absolutely anything that is possibly an answer for either one. So we have this graph of y is less than or equal to -2. We have this graph that is greater than 1. So our answer can be this graph or this graph. Either one can be part of our answer. So we have them both down there. Let's try a couple. A number x, so I'm going to write down x, is greater than -8. And there's our keyword, and x is less than or equal to 4. So if I'm going to put those two together, we have -8, x and 4. So our solution set then we have -8, -6, 4, 0, 2, 4, 6. We've got a closed circle at 4, an open circle at 8, and in the middle is where they're going to overlap. And again, we're talking about overlapping because of that word and. If I'm looking at number 2, we have y at most, remember, is less than or equal to 0. Or, so there's our keyword or, this is going to be a union. Y is at least, means greater than or equal to 2. So because it's an or, we put both answers on our paper. So 0, 1, 2, 3, 4. We have a closed circle at 0 because of the equal to. Less than is left. Closed circle at +2. Greater than is to the right. And those are going to be our answers. You try numbers 3 and 4. All right, compound inequalities with and. So this is another way that we'll see them as actual equations. And I'm going to show you how to do these 2 ways so you can see a way that maybe works better for you. First way is if I'm going to look at this all as one big old problem. And because I have 2 inequalities, I've got 2 walls to hop over. Here's our variable. So to get x alone, the opposite of subtracting 2 is to add 2. Now I have to hop over this wall to the right with the 3, but also to the left with the -4. -4 plus 2 is -2. We have the x, those add to 0, and 3 plus 2 is 5. X is alone, so this is our intersection. We have to go from -2 to 5. We have an open circle at -2, an open circle at 5, and if the x is squished in the middle, we're shading in the middle. And let's say that was just way too much going on, right? Let's try it a different way. I can write this as -3 is less than -2x plus 1, and -2x plus 1 is less than or equal to 9. So I can actually make this into 2 separate equations. If I'm solving the green side, the opposite of adding 1 is subtracting 1. Remember, subtraction does not change the direction of that inequality. Divide by -2. Now dividing by a negative does change the direction of the inequality. And so we have 2 is greater than x. And over here in the blue, we're again subtracting 1 from each side. Adds to 0. We have -2x is less than or equal to 8. Divide by -2. Dividing by a negative does change the direction. And so now what I'm basically doing is I want to slide these 2 equations together. And sliding them together means I want to overlap, because that's the same x. I want to overlap them. So 2, overlap those x's, -4. Or to make it look like the other and problems, we can pick it up and flip it. Again, making sure that the inequality here with the 4 opens to the x. Here it is again, opens to the x. This one opens to the 2. That one opens to the 2. So now I can put that -5, 3, 1, 1, 3. So we have a closed circle at -4 because it's equal to, an open circle at +2 because it's equal to. The x is squished in the middle, so we are shading in the middle. Now for an OR problem. An OR problem is going to work very similar to what we just did on the other page. The only difference is in the answer. So I have 2 separate problems. I'm going to start with solving on the left side. Add 5 to both sides. 3y, that adds to 0. -8 plus 5 is -3. Last step is to divide by 3 on both sides. That simplifies to 1. We divided by a +3. We don't care that that's negative up here. We care what we divided by. So that does not change the direction of our inequality sign. So our solution to that one is y is less than -1. Over here on the right side, we're going to add 1. That adds to 0, so we have 2y is greater than 6. Divide by 2, divide by 2. The 2 is reduced to 1y. We did not divide by a negative, so the inequality does not change direction. And 6 divided by 2 is 3. So remember, OR problems, we have both answers on our graph. So at -1, we have an open circle because it's not equal to, less than is left towards -infinity. Y is greater than 3 is an open circle at 3. Greater than goes to the right towards +infinity. And again, they both go on the same graph because they're an OR problem. Please try problems 8 through 11, and we will work on the word problems in class tomorrow. Thanks so much. Have a great night.